Happy Monday. So it's a Monday again, and I am not here, so you guys get a video again. Couple of things about this week. So we're going to have lesson 10 today on Monday. The homework tonight will be due tomorrow in class. But the big one here is that you are going to have a test, your next Unit 2 summative. So this one is going to be a summative, and it is going to be on Friday. But fear not, you get to use your toolkits, you get to use a calculator, all that fun stuff you get to use on that test, but that is a summative. That means no corrections on that one. Okay, so let's jump in here to lesson 10. In lesson 10, we're going to be talking all about linear functions. So we're going to be talking all about linear functions, and we are going to be starting on page 114. Okay, so this is going to be on page 114 right here. So Grandma Billings is making a quilt and piecing together a number of blocks. Zach and Sione are watching and thinking about predicting the number of quilt blocks in this pattern. So you've got pattern 1, which has 3 blocks. You've got pattern 2, which now has 5 blocks. You've got pattern 3, which now has 7 blocks. And you've got pattern 4, which has 9 blocks. Zach said, I noticed that 2 blocks are being added each time, which is true. 3 to 5 is plus 2, 5 to 7 is plus 2, 7 to 9 is plus 2. I thought it would be easier if I had the y-intercept, so I imagined what pattern 0 would look like by subtracting 2. So again, if we are adding 2 to go that way, we can also be subtracting 2 to go to the left. So if we need pattern number 0, then we would have to subtract 2 from 3. And so he said that there is 1 block at pattern number 0. So he wrote down this equation right here as his equation for the number of blocks in this pattern. Quick little check just to make sure that this works. If we have, so this x would actually be n, and this y would actually be capital B for blocks. Okay, so if we plug in 0 in for n, we get 0 times 2 is 0. Plus 1 is 1. If I plug in 1 for n, 2 times 1 is 2, plus 1 is 3. If I plug in 2 for n, 2 times 2 is 4, plus 1 is 5. So we got pattern number 1 for 3, pattern number 2 for 5, pattern 0, like Zach said, had 1. If I do patterns 3 and patterns 4, 2 times 3 is 6, plus 1 is 7. 2 times 4 is 8, plus 1 is 9. So the pattern holds with Zach's equation. I'm just going to call her Sia because I don't really know how to say that. I'm not going to lie to you. That's the first time that I've ever seen C1. Okay? So C said, I also noticed that the pattern was growing by 2 each time. I saw that pattern 1 had 3 blocks. Pattern 2 has 3 blocks plus 2 groups of 1 block on either side. And pattern 3 has 3 blocks plus 2 groups of 2 blocks. So she wrote this one as her equation, which looks very much like when we were back in Unit 1, we would have said this would have been the blocks was the first pattern, or the first entry in the pattern, plus the difference times n minus 1. We've done that before. It's on the back of your green sheet. Actually, sorry, not your green sheet, your green toolkit. It's on your green toolkit a lot, that one. We've done numerous ones like that. Okay? So question number 1 says, what does 2 times n minus 1 mean in this equation? Well, that means that's the number of groups, that should be a P, of 2 blocks being added. So that's the change, because remember we started with three blocks in Grandma Billings's pattern, and then so this would be the change here. Then this is going to be the change to that 3, so that's the number of groups of 2 blocks that are being added. Okay. Question number 2 asks if Zach and C's equations are equivalent. Equivalent means that they're the same. Okay, so let's see if they are the same. Well, if they're the same, then they're going to be equal. So Zach's again was 2n plus 1. C's was 2 times n minus 1 plus 3. If those are the same, then we can rearrange the one that we can do more to. The one that looks like you got to do a little more work to, that's the side that we're going to rearrange. In this case, it's this right side. So I'm going to distribute that 2 into both of those. So 2 times n is 2n. 2 times negative 1 is negative 2. And then plus 3. And then I can't do anything with the 2n. The 2n is going to stay 2n. There's no other n terms to combine. But negative 2 plus 3 is positive 1. And now we've got Ben's equation, or excuse me, Zach's equation. So they are equivalent. We knew that they were going to be equivalent because they both worked. We checked them both in our pattern beforehand. So yeah, they're equivalent, and we just showed it. Now they got another person named Marcus joining the conversation, and he noticed this. He was focusing on the strip of blocks in the middle, looking at patterns 3 and 4. He thinks that he could write B equals 2 times the quantity n minus 2 plus 5. And he could write the quantity, or B, the number of blocks, is equal to 2 times the quantity n minus 3 plus 7. Okay? Do we agree with Marcus? Well, if we are agreeing with Marcus, then we should check to make sure that they work for them. So back up on the original one, on pattern number 4, there were 9 total blocks. So if we plugged in the pattern number into both of those equations, we should get 5 for pattern number 2 and 7 for pattern number 3. So let's do that right now. So let's go pattern, correction. We should get, if I plugged in 4 for the pattern number, we should get 9. Sorry, I misspoke there. I was getting ahead of myself. So in the first one, I don't need pattern. I got pattern written already. Come on, Linz, be better. Okay? So if I go B here equals 2 times the pattern number, which is 4, minus 2 plus 5. So I'm plugging pattern number 4 into that equation. 4 minus 2 is 2. 2 times 2 is 4. 4 plus 5 is 9. So we have pattern number 4. We plugged in pattern number 4, and we ended up getting 9 blocks used. So the red one works out. Now let's try the other one. So now I'm going to try this one. Again, I'm going to plug in 4. But now it's minus 3 and plus 7. So again, I'm plugging in 4 into my pattern number. Or I'm plugging my pattern number into the equation. 4 minus 3 is 1. 1 times 2 is 2. 2 plus 7 is 9. And it worked out that we got 9 again there. We can show that all of those are equivalent by just simplifying. So if I take this red one, 2 times n minus 2 plus 5, and I simplify it, again, by distribute the n into both of those. That's going to give me 2n minus 4, then plus 5, and that gives me negative 4 plus 5 is positive 1. So there is Zach's equation once again. If I do the same with the purple equation, distribute the 2n minus 6 plus 7 gives me 2n plus 1. So we've proved that those are equivalent to Zach's equation. What's going on here? I'm going to look at a table to see if I can see why this is working. So they made a table and noticed a pattern in the table. So they used what was the guy's name? Marcus? So C used what Marcus said, okay, and found the equation this time using pattern number 4. Okay? Well, that works because, picking a color here, that right there, that is as long as, oops, I made my bracket a little too big. Sorry about that if you had already written it down. This right here, we'll go in purple this time. That right here is my term number. So that's the term that it's going to be, and that works. And then this right here is the amount of that term number. So Zach is saying he doesn't need the table because the next one here would be term number 5, and it would need to have 11 blocks because I'd have to add 2 to get the next one. So Zach put the term number here, there's our 5, and Zach put what terms it should be right there, and it worked out. Okay, which was basically number 4. I just did it for you right there, which is just fine. We can do number 4 right there. So now, if we wanted to use C's method to find the equations of these tables, the first thing that we've got to find is we've got to find the rate of change. The rate of change is going to be the change in y over the change in x. So you pick any two value or 2 points in your table or on your graph, or if you're just given 2 points, and you subtract the y's and divide that by subtracting the x's. Okay, so 55 minus 50 divided by 33 minus 32. 55 minus 50 is 5. 33 minus 32 is 1. So the rate of change here on this one is we're going up by 5. Okay? Or you could have seen here, because these are going up by 1, this is going up by 5. There is my rate of change there. Then, step 2, C's method is going to be y equals that rate of change times x minus the x part, or the input, if you will, then plus the y part of your point, or of your line. Okay? So right here, this equation for this chart would be y equals, my rate of change is 5. If I choose the first line, it would be x minus 32 plus 50. Oops, I ran out of space. Maybe I can move this down here a little bit. Oops, tap the brakes. If I choose the second line, x minus 33 plus 55. If I choose the third line, I'd have y equals 5 times x minus 34 plus 60. And those all are equivalent equations based off of just that scenario right there. When you go over here to letter B now, they're not going up by 1s. They're going up by 2s. So you have to definitely bring that into play. So we could go here 78 minus 70 all over 26 minus 28. Now some of you might be saying to yourself, Linz did it in the opposite way last time. Well, let me show you this crazy math. We're going to go 70 minus 78 all over 28 minus 26. Those two are going to be equal. Watch and learn. 78 minus 70 is 8. 26 minus 28 is negative 2. 70 minus 78 is negative 8. 28 minus 26 is positive 2. Either way, the rate of change is negative 4. So if we pick the first one, y equals negative 4 times x minus 26 plus 78. Y equals negative 4 x minus 28 plus 70. Or, see if I can fit it in, negative 4 x minus 30 plus 62. What I would like you to do now is I would like you in your groups, I'm going to give you 3 minutes to do letter C. Find me one of the equations. You don't have to find me all 3, but you can find me one of the equations for that. Go. 3 minutes. I'm going to let the video run because then I can track the video. Quick spot check here. I know it probably scared some of you because I was quiet there for a while. 32 minus 39 all over negative 15 minus negative 14 would be negative 7 over negative 1, which would be positive 7. So we should have gotten a rate of change there of positive 7. If I use the first one, it's going to be y equals positive 7 times x minus negative 15, then plus 32. Now, we don't write that negative or minus a negative there, so we would prefer this one to be x plus 15 in the parentheses there. Okay, so if that x value is negative, then it switches to a plus inside the parentheses. So that's the first one. If you use the second point, it would be that. If you use the third point, it would be that. Okay. Love it. What information do we need to write an equation using this method? Well, what we need is we need to have the rate of change which we just found. You probably didn't realize it, but when we subtract the y's over subtract the x's, I jumped back a page here now. When we subtract the y's over subtracting the x's here, this step number 1, that is actually finding the slope. So this is the slope of our line. And we need a point on the line. So if we have a point on the line and we have the slope of the line, we can find it. Or if we have 2 points on the line, we can find that because we can find that change in y over change in x. Like here in number 7, I've got 2 points on the line. So the first thing I could do is I could find the change in y's over change in x's. So I could go 3 minus 1 all over 8 minus 1, which would be 2 over 7. I could go 1 minus 3 over 1 minus 8 and get negative 2 over negative 7, which is a negative divided by a negative, is positive. Or I could do, I rose 2 and I ran 7 to get it. Either way, rise over run, change in y's over change in x's, all gets me 2 over 7. So my two equations would be y equals 2/7 x minus 1 plus 1 is the same as 2/7 x minus 8 plus 3. Okay. Both of those get me that equation of that line. Question number 8. We have the slope. It's -3. We have the point, -1 comma -5. So that's going to be y equals -3 times the quantity x minus -1 plus -5. So we write that nice and pretty in math speak. -3 minus a negative right here, minus a negative. We don't write, we write that as plus, and plus a negative. We don't write that either. We write that just as -5. So that would be the equation of that line going through -1 comma -5 with a slope of -3. I'll give you now 2 minutes to find the equation of the line through the point 1 comma -3 and the point 3 comma -5. 2 minutes. Try it now. 30 seconds. All right. So first thing first, got to find my slope. M is the symbol for slope, FYI. -3 minus -5 all over 1 minus 3. Or we could have also done -5 minus -3 all over 3 minus 1. In either case there we get 2 over -2, or we get -2 over +2, but either way that reduces down to a slope of -1. So my y equals equation, if I use the left point first, that's going to be -1 times x minus 1, then minus 3. Or if I use the right equation, y equals -1 times x minus 3, then minus 5. Should have been what you got there. So on this one, I'm not going to graph it. This video has gone on long enough. I know that you're getting kind of bored with having a video on a Monday, but it just is what it is. So let's talk about the starting point. Let's recognize the starting point first. So this should be x minus the x part of the point. Well, it's right now it's plus, so that would be x plus 1 is really x minus a -1, kind of working ourselves backwards off of that one. So my starting point is going to be at -1, comma, and then we just have whatever's on the outside is the y part, so then that's going to be -3. The real lesson to think about here is in blue, inside a set of parentheses in math, we think oppositely. So it looks like +1, but it really, when I go to use it, it's -1. And then the slope, the rate of change, if you will, comes from the number out in front of the parentheses, so that's -2. And this all works. Zach's wondering here in number 11, Zach's wondering why this is all working. It's because these are lines and the rate of change is the same on lines all the way through, no matter where you go. Okay? That's 35 minutes. That's 2 mods worth. So your takeaways from this are the point slope form comes from the slope formula of that. Okay? And we can get all that stuff. Give you a second to write this down. Then, this is your homework. It is due tomorrow. I would really, really like it if you started it now.